Alright, hey, so this is me, Motosim. I'm going to do part 3 of Osbe's lab. Um, Here, let me write my name here so you know it's me. So, yeah, so I'm going to do part 3, and then he requires the 60 hertz of part 3 to be on video, so that's what I'm going to do. So, the first thing is to open Fluent, which I already have since I run the 30 hertz, so I'm going to do the 60 hertz now, and then you want to import. Obviously, right now it says export, but because I did the 30 hertz, but it's gonna say import, you import it, then you double click geometry, and let's see, it's gonna open. All right, yep, it opened on this window, so I'm gonna drag it over. So this is the geometry right here. The 10-degree angle flat plate is right there, and obviously you have to click generate, but mine is already generated, so I'm not gonna worry about that. Get out of there, and then this is where we're gonna mesh. Let's wait for that to open. It's loading. Da-da-da. So here we have the mesh. So over here the first thing I had to do was select the name selection. So as you can see, I labeled the velocity inlet this, the outlet that, the walls one of them, and then the plate you have to label separately, or else you're not gonna get the right force and stuff. So this is a plate. Then what you want to do is click on mesh and then generate, but mine is already generated, so I'm not gonna do it. The mesh I decided to choose was 0.003 because I found this works the best, gives the best results. And we're using triangle geometry. And if you look at the mesh, it's very fine mesh right here. This is a plate. These are triangles, and this is what the mesh looks like. And then again, you want to click generate and update, but mine is already, it's the same for 30 hertz and 60 hertz, so I'm not gonna change the mesh. Well, I guess we'll find out, right? Once we do the running. So over here, you want to do the setup, you want to click OK. So what you want to do is click 2D, so it's either double precision 2 here, and then click start, and it's going to start it. So we have the Fluent open right here. You want to click OK. Yeah, nope. Okay, let's see. You want to click OK right. Okay, so now it's open. So click OK. As you can see, the inlet's right there, and the outlet is right there. So it showed up properly. And then what you want to do is make sure our properties are good. So you want to come in here, go to materials, make sure it's fluid. The fluid is air, which it is. You want to go to models, make sure the energy equation is on. Since I just run the 30 hertz, it's already there. And then you want to make sure the viscous is set right here. You want to make sure it's K epsilon, standard, enhanced wall treatment, pressure, gradient, and thermal effects. So yeah, that's it for this. Get out of here. And then, whoop, where's my mouse? The next things are to check is the boundary conditions, the inlet. You click on the velocity inlet. Since this is this 30 hertz velocity we calculated, I'll show you the for 30 hertz we calculated 2.29 for over here. We're gonna copy this. For 60 hertz, we're gonna use 4.709477. So I'm gonna Control C, minimize, Control V here, then click apply. Everything else should be the same. Cross out here. Let me just make sure it wins. Yep, it's saved. Okay. Yeah, so that's the only thing that changes for 60 hertz. Everything else is the same. You're gonna click here. You want to initialize. It's initializing, it's done, and then you want to run calculations. Double click here. Yeah. So for run calculations, I'm doing 150 iterations, one interval, and everything is good right here. And then I'm gonna hit calculate. You can do more, but it's just gonna take a long time. And for the video, I don't want it to take a long time. Just running the calculations right now. Alright, as you can see, it's done with calculations. I'm gonna click OK here. Go back to Workbench. Click results. So right now I already have all of this. I'm gonna get it out so you can see. Oh, I think this is required. Okay, so the first thing you want to do is click on here the pressure contour, click on it, and then create a contour and click OK. Since I already have it created, I'm not gonna click it again, like do it again. But it's right here, simple. Once you click OK, it shows up right here. And you want to click symmetry 1, and then everything else stays the same, and apply. So this is what the pressure contour looks like for the 60 hertz right here. Also, I wanted a zoomed in picture, so I'm gonna do that as I go. Actually, let's do this so you can see its actual contour. Alright, let me save that. Alright, and then next you want to click create the streamline. You click here. You create a name and then click OK. I already created it right here. So you want to uncheck pressure, double click on streamline. You see the settings that I selected, symmetry 1, everything else the same. I'd select the 60 points. And then this is what it looks like. Let's do 70 for this. Let's try this. Yep, it's more like it, I think. 70, just the point across. So I'm gonna click on the snippet, snip this as well. This is the velocity streamline. The second to last part is the velocity vectors. So I'm gonna uncheck this. You want to click here and then select vector, click OK. I already created it right here. I'm gonna click on it, and these are the settings. And this is what it looks like. As you can see, the velocity difference right here because of the 10-degree angle that it creates. Right here. And then I'm going to take a snippet of this for Osbay. Then we got this as well. And the last thing to do is calculate pressure, lift and drag. So we're gonna get out of here, go back to setup. You want to go on solutions. You want to click report definitions, and then you want to click new force, and then you want to click drag first. These are default settings. We want to select the plate, and then lastly, we want to drag force, not coefficient, and then compute. Click OK. Click close, and it computed the drag right there. So I'm gonna take a screenshot of that as well. And then have it right here. And then the last one is the force, lift force. So I'm gonna click here again. And it's like so, new force bars lift. And then it always shows up on that window, but I got it right here. Lift force, plate, and then hit compute, and hit OK, and hit close, and there we go. This is the lift. As you can see, the lift is greater on this than the flat plate one because obviously this is a angle of attack. Um, yeah, that's pretty much it for this lab. And then I'm gonna use this and this this Excel sheet to calculate. I'm gonna use the drag force. I'm gonna add another layer here for the 10-degree angle, and then put the drag force here and use that equation to calculate the drag coefficient. I'm gonna do the same thing with the lift. So yeah, that's it for this part C, and yep, good to go.